Good afternoon. Welcome to our lesson today. Just a minute. I will start educating you. So, good afternoon. I hope you're fine. Now, all the way up to 4 p.m., I hope just engage with me through the chat section. I will be able to respond to you, write to me, I'll be able to talk back to you, and we are going to discuss the small part that is remaining on the part of the measurement, which is density. Actually, I started density at that point. I want us to finalize the density term is that force. So, if you want to watch all the other videos from the beginning of the physics for 1 up to now, just go back to our channel, that is Ambassador Foundation Learning Channel. I dare you go through it, you will never regret. So, I have a pleasure. Welcome to our lesson. So as you're watching me, you can write on the chat section, you can write where you're watching me from, tell me where you're watching me from. You can mention the teacher of your physics, Pierre Praye, because most of them are following later on these lessons. So I invite you, we continue together. Thank you. Reagan, Juliet, how are you?
Fine.
Fine. So let's proceed with our discussion today. There's a small part I want us to finalize, and that is the part on density. Tunatumali kidogo kumalizia density, lakini tutamalizia leo, then we start force. Yeah. So let's be there. Let's be very keen. Let's follow up and see where we stop. What did we say? Who can define for us density and give us the SI units of density? Now we're hoping you are also you are going to do it. Can you define this and give us the SI unit of density?
Density is mass per unit volume.
Yeah, mass per unit volume. So what's the SI unit of density?
Kilograms per meter cubed.
Yes, how do we change the use of this from kilogram per meter cubic to grams per centimeter cubic and vice versa?
To change from grams per centimeter cubic to kilograms per meter cubic, we multiply it by 1,000.
Yes.
Multiply it from kilograms per meter cubic to grams per centimeter cubic, we divide it by 1,000.
Nice. That's how it should be. Yes. So let me talk about this bottle. Let me discuss about this bottle for the next few minutes. Then we shall proceed. We are going to play with the bottle. This bottle. Let me share the screen so that you can see it. So as you can see, what I want to draw, and this bottle is a container that looks like this. It looks like this. So it has it has a small container with a neck and a stopper. So this part is the stopper. This part is the stopper. And down here, we have the neck. There is a part here which we are calling the neck. What is the role of a nest bottle? What is the role of a nest bottle? The nest bottle is used to find the density of liquids and solids. We are going to explain how you can use a nest bottle to get the density of liquids and solids. It's something that is very simple. Then we will discuss one example on how to get the density of a liquid or a solid using the density bottle. Yes. So now, first of all, before we see an example, there are things that we need to discuss on. One is the precautions when using a density bottle. Density bottle is so delicate when using it. Some of the examples or some of the precautions held by the neck, meaning you cannot just, if this was a density bottle, to make the liquid in that particular density bottle to expand. Yes. Number two, the outside of the bottle must be wiped dry carefully. Because we have to wipe actually outside the bottle, we have to wipe out dry and you do it carefully. Why must you have to wipe it dry? You have to wipe it dry because if you don't wipe the water outside the next bottle, it will be part of the mass that we are going to record. So it should be wiped out dry. Now, the other precaution is that there should be no air bubbles when the bottle is filled with the liquid. There should be no air bubbles when the bottle is filled. If you have the magic or whatever the liquid, then you see some air bubbles. You need to shake it to ensure that the air bubbles are not there. Because if it has some air bubbles, then it will be very inaccurate. So it should be having no air bubbles for it to be very accurate. Remember what I said? It is used to make the density of both liquids and solids, not just liquids, but liquids and solids. After going to together, yes. So what's the next thing? I want to give an explanation using that particular example. Let me write this example on the board. I can wrap the word physics because you have already known that we are discussing physics. So the question is the mass of this bottle the mass of this bottle is 20 grams when empty. So even before we continue from there, that statement is very simple. It means that the mass of the density bottle was measured when it is having no liquid and it is 20 grams. That's the first statement. When full of water, it is 70 grams. So I put a comma. Then I write this 70.0 grams when full of water. After doing, what conclusion can you bring? 70 grams when full of water. But remember, it is 20 grams when empty. What is the mass of water that can fill the density bottle? 70 minus 20. So the mass of water that fills the density bottle is 50 grams. Let's continue with the question. And let me use the word and 55.0 grams when full of liquid X. Yes, when full of liquid X. So here we have three things. When empty, when full of water, and when full of liquid X. When full of water, my point is 70 grams. When full of liquid X, my point is 55 grams. So it's very simple. One thing about that, mass of water. Okay, first of all, the question is calculate the density of the liquid X. Of the liquid X. Good. So let's move into step one. Mass of water. Mass of water is going to be 70 grams minus 20 grams. Why? It is 70 grams when full of water, meaning the mass of water plus the density bottle is 70. Then the mass of every density bottle is 20 grams. So we have 50 grams. That is the mass of water that can fill the density bottle. There is something I want to say. That hii container nikijaza maji it is 1 liter. Yeah, hii bottle ni ya maji ya 1 liter. If I fill it with water, the water is 1 liter. If I fill it with another liquid that's water, maybe I fill it with kerosene, it will still be 1 liter. What will change is the mass because they have different densities. So if I fill this container with water, then with water, then I fill it with liquid X, the volume will remain the same. I don't know whether you're following me. Yes. Now, on special conditions, always the first liquid that you are given to fill the next bottle is water. Why? Because the density of water is always 1 gram or not. Just know that the density of water is 1 gram per centimeter square. What does it mean? It means this. For every 1 gram of water, its volume is 1 centimeters cubic. If I have 10 grams of water, the volume is going to be 10 centimeters cubic. If I have 50 grams of water, the volume is going to be 50 centimeters cubic. Did you get it? Now, we have the mass of water that fills the next bottle as 50 grams. So, what is the volume of water that fills the next bottle? Taking into consideration that the density of water is 1 gram per centimeter cube, so it's going to be 50 centimeters cubic. Up that point, are you together? Boys and girls?
Yes.
Good. So the density bottle has a volume of 50 centimeters cubic as per this question. Now, let me ask another question. What will be the volume of liquid X that will fill the next bottle? Somebody tell me. You don't need calculation, just mention it. Yes? Again? What is the volume of liquid X that will fill the next bottle? We have pardon?
50 centimeters.
Yeah, it's going to be 50. I say, if I fill this container with water, 91 liters, if I change the liquid, I use another liquid, 50 centimeters cubic of water can fill the next bottle, then volume X is going to be 50 centimeters cubic. Common sense. If it can be filled by 50 centimeters of water, whatever the liquid out of the change, it will still be the same. Yes. Sabrine is watching me from Wajir. Thank you, Sabrine. When you come to school, anybody mwenye ana make a comment, akifika shule anakula kitu. So now, if you have the volume of liquid X to be 50, angalia hapa. When this bottle is filled with liquid X, its mass is 55 grams. But the mass of empty bottle is 20 grams. What is the mass of liquid X? Mass of liquid X. What is the mass of liquid X? Very simple. 55 minus 20, you get that 5 grams. Up that point, are we together? Where is my good friend Michelle Mugai? Up that point, are we together?
Yes.
Okay, so. Now, if we have the volume of liquid X and we have the mass of liquid X, can we get the density of liquid X? Is it possible?
Yes.
How? Density is given by mass over volume, which is going to be that 5 over 50 by 10 by 5, 10 by 5, 7. We get 0.7 grams per centimeters cubic. Kuna mtu alikuwa amelezi mkono, niambie ulikuwa unasemaje? Good. Now, what's the question saying? Calculate the us what do we call it? It has not given us conditions in SI unit or not, but you can still convert it in the SI unit. How? By multiplying 1,000. So if you have any question, you can ask me on the chat box, or if you have any question, you can unmute and ask me as we are moving to the next question. Let's proceed. Kuna swali hapo. I hope you can see on the screen. I will write for the sake of those who are following me, for the sake of Sabrina. Sabrina, how are you doing? We have a question here. I will read on the beginning of the question. The question reads, in an experiment to determine the density of a certain solid B, the following readings were obtained using a density control. So the solid is solid B. The solid under question is called solid B. Now, kuna information tumepewa, and I want us to use the information very well. The first information is mass of density bottle, mass of empty density bottle. Mass of empty density bottle. Mass of empty density, aina kitu ndani 8 grams. Just kwa wale paka nikumeito iko empty. Empty 8 grams. Now, number 2, mass of density bottle and solid B. Mass of density bottle, dB, and solid B. Sasa tumeweka solid B ndani ya density bottle ikatupatia 96 grams. Katupea ngapi? 96 grams. Katupea ngapi? 96 grams. So hapa hii 96 grams ingine ni ya solid D, ingine ni ya base protein. Tuendelee. I want you to be very keen because kuna mahali hapo nataka ushikilie. Nasikia like
Yes.
right. Number 3, mass of this bottle plus water and solid. Now let me now this way. Kuna wale watu mnapendanga kula, nimesahau jina yake, lakini there's some food unanunuanga super, unaweka kwa kikombe na unaongeza maziwa ama chai, then you use a spoon to eat. I don't know what's the name. Ama
Weetabix.
good Weetabix. Because you see, our Weetabix when you are growing, I don't know whether Nepali can understand what I'm saying. Ukipika ugali vizuri kwa sufuria, ukishaondoa ugali, so kuna ile inaitwa na ile inabaki ndani ya sufuria. Siulikumbushe? Hiyo okay, tuachana. Sasa hiyo sisi ndio tunatoa tunaweka kwa kikombe na unaweka chai na unakunywa. Now, let me use what Regan has said. Ukichukua Weetabix na ujaze kikombe vizuri mpaka ijae. Bali mpaka ijae mpaka to. Ukimwaga chai ndani ya maziwa, bado itapata space ya kuingia. Sio kweli? Ukimwaga chai ama maziwa, see, it will still find its own space then. Exactly, that's what's happening right now in this question. Tumeanza hivi. Tumeanza tukaweka solid D. Tumeweka solid D ikaweigh 96 grams. Tukaongeza maji ikaweigh 132 grams. I don't know kama let like this. Mass of this bottle plus water and solid D. Plus water plus ama solid or whatever, give us 102 grams. But kumbuka pale tu tumeambiwa the mass of empty this bottle ni 8 grams. Sawa sawa. Kwa swali yetu pale tumeambiwa the mass of water ni 30 grams. Now, solid D, what is the mass of solid D? Because ikiwa empty, this bottle 8 grams, ukiweka solid D 96. 96 minus 8. Where's the 8 grams? 88. So about equal 88 grams. Can you confirm for me, somebody? If 8 plus 30 plus 88, what is it? Because kuna mahali hiyo swali imepotea. Hebu kwa sababu sasa ndio unaige. Can you add 48 plus 30 plus 88? Bado
126.
126. Kuna mahali imepotea. Commit kupea mass of water. Sema 30 grams. But from our second statement down there, mass of this total plus water ni ngapi? Mass of this total plus water. Imeambiwa ni 88 grams. Can we get the mass of water? Because the mass of solid D, ukitaka mass of solid D, unasema 96 minus 8, unapata 88 grams. Now, ukitaka the mass of water, kumbuka umeambiwa mass of this bottle plus water ni 88 grams. Now, ukitaka the mass of water, itakuwa 88 minus 8. Unapata hiyo gani? 80 grams. This is the mass for water. Kuna mahali tu imechanganya kidogo, lakini usijali. Swali, I think I did not correct the question very well, but no problem. Now, in all this, we are supposed to calculate the density. We are supposed to calculate the density of solid B. And for us to calculate the density of solid B, we need its mass, whereby we already have the mass 88 grams. And now we want to get the volume of this particular solid B. Now, so in order to use it, if this bottle, which is of mass 8 grams, was filled with solid B, it can be like a bag of 96 grams. So the mass of solid B is about 88 grams. How can we get the volume of this particular dense bottle? We shall find the volume of the dense bottle, then we shall be okay. Now, hapa tumeambiwa mass of this bottle, water and B, the one that 2 grams. Is it possible we get the volume of water? Is it possible we get the volume of water? Because the volume of water that fills this particular dense bottle. Kama tuko na mass of water that fills the dense bottle, kama 80 grams. Na inafaa tukia this, hapa kuna mahali wali ni 8 na yote inafaa ikuje 132. Hebu nifanyia kwa hii nisema 132 minus 88 plus 8. Tuone inatuletea ngapi. 132 minus
96.
Madama?
96.
Okay. So the mass of water is 36 grams. So it means we are going to improve. This one is better than what we needed. So hii ingine tuachane nayo kwanza. So it's 36 grams. Let's use that information so that now we can get the volume of the density bottle. Now, tell me now here, because we are supposed to get the volume of the density bottle, and then in that volume of the density bottle, we remove the volume of water, because the volume of water, if the mass of water is 36 grams, automatically it is going to be 36 centimeters cubic. So the first question that we are being asked here is this. From the information we have. The first question is mass of water. The question has already given us the wrong thing, because it is what the information might be. But the mass of water come at 80 grams, at the same time, if the mass of water come at 6 grams. So if you work with what it has given us over there, it's going to be 0.08. So I work now. This one here we work now 80 grams of water, which is I may find the kilogram, 0.08 kilograms. Then the volume of water, of course, unajua ukishapata the mass of water, you can easily get the volume of water. It's the same. Kama ni 80 grams, then the volume is going to be 80 centimeters cubic, or you can convert it into meters cubic. Then the volume of the density bottle. Let's use the former information. Density bottle alone and water ilitupatia 88 grams. So meaning tukiondoa 8 grams ya density bottle, then 80 grams is the volume of water in the density bottle, which is also the volume of the density bottle. So the density bottle, I think I mixed a lot of values here, but no problem. The volume of the density bottle is 80 centimeters cubic. Now, mass of solid B, to examine 88 grams, then the density of solid B is its mass, which is 88, its mass is 88 divided by the volume. Its volume. So kama tumepata kwamba the volume of the waste bottle ni 80 centimeters cubic, to avoid the volume of water, which is 36. 80 minus 36 negative. Just do for me, I will add 80 minus 36. So it is 18 divided by 44, and you will get as 2. Ignore my working is here because it will not work. But I'm going to correct that question after this. So let's do this one question again. Alafu niwape ingine. Let's write that on the board. Are they total? Can you be doing that question so that we do it together? For those when your words is not like, after reading the question you can pause the video, then you do the podcast. So it is this way. Ades total has a mass of 17 grams on hand. Ades total has a mass of 17.5 grams when empty. When full of water, its mass is at 0 grams. So there is the bottle plus water. It will give us that 7.5 grams. When full of liquid X, its mass is at 12 grams. So there is the bottle plus liquid X is contained at 5 grams. I'm at 5.0 grams. Then, of course, if the density of water is 1 gram per centimeter cubic, calculate the density of X. Calculate the density of X. Just 1 minute, please wait first. Bagan naik. Untuk banyak begini. Macam-macam 0.875. If that is the true answer, mungkin awak kamera kan? Sabri, where have you gone? Yes, so let me do this question very fast. You are being asked about the density of liquid X. So the mass of empty density bottle is 3.5 grams. Density bottle plus water is 7.5 grams. So mass of water is over. Mass of water is going to be minus 17.5, okay? Reckon that 7.5 minus 17.5. Yes?
17.5.
Oh, this is 17? Yeah, it's going to be minus 17.5. Go back one. That's what we it is 20 grams. Now, so E mass of water is 20 grams, which is also the volume of water that fills the next bottle, which is also the volume of the next bottle, which is also the volume of liquid X. So, in summary, volume of liquid X, volume of X is called centimeters cubic. What about mass of liquid X? Mass of liquid X is going to be mass of liquid X, that 5 minus 17.5. Everybody else doesn't reckon that 5 minus 17.5. Now, in back, snack calculator.
17.5.
17.5. Grams. Kama kawaida, you got to calculate density. Density is given by mass of a volume. So mass is going to be 17.5 divided by volume, which is 20. Kumbuka ni grams, centimeters cubic. Now take your calculator, especially those who have them. Can you say 17.5 divided by 20? Yes, Stephanie? 0.875. 0.875 grams per centimeter cubic. That is it. Yes, any question? Next time about 87.5. Can you work on your calculation zuri na Nasri? We can go from there. Nani wako na swali? Are you satisfied, Regan?
Yes.
Michelle? Definitely, of course, you have the answer. That's okay. Now, let me handle another concept: the density of mixtures. The density of mixtures. Density of mixtures. Density of mixtures. Let me explain this. Have you ever heard the meaning of the word alloy? Maisikia maana ya alloy? Alloy.
It's a mixture of metals.
Yeah, when two metals are mixed together, for example, brass is an alloy of copper, tin substances with different densities. Like you mix 800 kilogram meters cubic, 0.8 grams per centimeter cubic. You're going to come up with a mixture that has a different density from the density of the two substances making up that particular mixture. In most cases, the density is in between the densities of those two. Don't make a blunder of getting the average density to be very low. We don't get the average. Average will be low unless the masses and the volumes used are equal, or simply the masses. But still, the best way is apply this formula. density of a mixture is called total mass over total volume. Total mass over total volume. Hapo tuko pamoja. Total mass of the mixture over the total volume. If you are given a mixture of water and ethanol, or water and whatever the two mixtures, get the mass of each one of them and the volume of each one of them. Then you will easily apply that formula. There's an example here. I will read for the sake of those who are online. Let me read very fast. The question is, a mixture contains or consists of 1 centimeters cubic of water and 60 centimeters cubic of liquid X. A mixture consists of, so here we have water, then we have liquid X. You know, we Nambiaka, once I take a water can, I take a liquid X can. It will be very simple for you. You see how we will do it now. So the question is, a mixture consists of 40 centimeters cubic of water and 60 centimeters cubic of liquid X. If the densities of water and liquid X are 1.0 grams per centimeters cubic and 0.8 grams per centimeters cubic respectively, meaning water has a density of 1, liquid X has a density of 0.8. Calculate the density of the mixture. Calculate the density of the mixture. So, upper, and take a density, and take a mass, then and take a volume. The same with this other one. Density, mass, then volume. So from the question, the density of water is 1.0 grams per centimeters cubic. From the question, this is 0.8 grams per centimeters cubic. What else are we doing from the question? The volumes. Water. Ingine volume yake ni 60 centimeters cubic. Now, from the information we have, let's get the mass of all of them. The mass of water is going to be 1 gram. Sorry, it's going to be 40 grams. Why? Because the density is 1 gram per centimeter cubed. What is the mass of liquid X? If density is given by mass over volume, so mass is going to be 40 times density. So 6 times 0.8. When you have 6 times 0.8, but the mass here, X. When you have 6 times 0.8. Yes, definitely. Ni kama nakata 60 times 0.8. First of all, it should be less than 60 because we are multiplying 60 with a number less than 1. Again?
48.
Yeah, it will be 48. 48 grams. I don't know what my friend doesn't means. Mental correction. So density of a mixture is equal to total mass which is 40 plus 48, over total 40, which is 40 plus 60. Once the 40 plus 48, you need 88 grams. Divided by 100 centimeters cubic. I will not put value to the pneumonia A equal than y here 0.88 grams per centimeters cubic. Apa tugas pamannya? Mana apa soalnya? Nanya apa soalnya tuan we can proceed. Akan wape swali ingine. Let me read this question for those who are online. The question reads: a solution contains 40 centimeters cubic by volume of alcohol and 60 centimeters cubic by volume of water. If the density of the alcohol is 0.09 grams per centimeters cubic and the density of water is 1.0 grams per centimeters cubic, calculate the density of the solution. So you have their volumes, 40 and 60 of alcohol and water respectively, and the density is 0.79 and 1 respectively. Calculate the density of the solution. You expect it to come because the previous questions we've done was on the same. So make sure your answer is 0.916. Yeah. So I want to discuss something next about time, how to make time. So what is time? I'm not asking what is the time, I'm asking what is time. Ndaka tuanzie hapo. Can you say that a time is the measure of duration and the SI unit is seconds? That is the meaning of the time. And this second has other units which we can use it. Like minutes, hours, milliseconds, microseconds, all through EPC. Now, 1 minute is always 60 seconds. You wake up with 1 minute in 60 seconds. I'm going to the 1 minute. One minute, 60 seconds. Don't write SEC, and in full seconds. 1 hour, how many seconds? 1 hour be 60 minutes, which is that 600 seconds. That's 600 seconds. 1 day. 1 day. One day equal to 24 hours, which is 8,400 seconds. Which is 8,400 seconds. 1 second. So that to be 1 second is equals to 100. And second moja is 100 second. Hii 1 second ni kidogo. Ukigawa ndani inakupea 100 second. Alafu hiyo 1 second is 1 million. Sasa nataka ujiulize ni nini hiyo unaweza divide 1 second in 1 million microsecond. Microsecond. The symbol for micro is you write something like 10x microsecond. You understand like how to do it. I was telling some people somewhere how time flies. Look here, let me explain something. That say one thing. This is all. In fact, apart from this, tuko na months, kwanza tuko na weeks, tuko na years and centuries. Let me give you a second is important. 1 second is important, but not to a farmer. Not to someone who wants to invest. For example, one day, there's someone, a friend of mine, alikuwa amebakisha 2 years to retire. And these 2 years to retire, this guy had not invested in it. He had not been married. I mean, everything was off. So we mtu watu wakimbia 1 year, haitamsaidia. Hii 1 year ni kidogo sana. Ya tatizo anausha gedoa 30 years. Hiyo haimsaidii. Hizo 1 year ni kidogo sana kwa mtu kama huyo. A student, a candidate mwenye sasa hivi anafanya mtihani. For them now, ukimwambia 1 hour to exam, huyu mtu mwenye hapo amefanya ile investment, alikuwa tukaza ile investment, ukipea 3 days haitamsaidia. You see how 3 days is important to a student? mwanafunzi imekaribia mwezi mmoja atakwambia nipe 2 months and cover the syllabus. 2 months itamsaidia, lakini 3 days haitamsaidia. Lakini mwenye shaka kwa syllabus anangoja tu revise even a day is enough. Now look here. Athletes who are running a short race. Si mnajua short races kina Omanyala, kina Tepogo wa Botswana, kuna huyu wa USA anaitwa nani? Mtu akikumbuka ataniambia, the sprinter from USA mwenye anakimbia mbio sana. We have the retired general simuniambia mtakuwa anakimbia kama kupita zamani. Amtaniambia from Jamaica. Aya. For them, 1 second was so important because mostly akona 9.65. Yani difference ni kidogo. So if you think 1 second is not important, uliza watu wa sprint, those who are running. Haya. Alafu sasa kuna wale wa long races kina Kipchoge na wengine. Unasikia mtu anamaliza marathon na 2 hours 6 minutes. Winner number 1. Number 2 is 2 hours 7 minutes. 2 hours 10 minutes. So these people, minutes is very important to them. So time can vary depending on how it is. So do you know how to convert time? Now let's get to this very important thing. How do we measure time? How do we measure time? Reagan, I will go, man. We'll see what out to Germany.
We can measure time using a stopwatch.
We can measure time using a stopwatch or
a stop clock.
A stop clock. But at what point do we require a stopwatch? When accuracy. Are you together?
Yes.
When we need. Lakini kwa klasi yenu pale mbele mnakuwaka na stop clock imewekwa pale. Na kuna wengine they will take 1 minute kuona nzanga anaangalia the short hand clock iko wapi, angalia the long one, angalia by the time analema is 12:30 anakuwa ameendeseka sana kwa hii dunia. So ukiona klasi yenu haina stop clock, venye walimu waliwaona wakaona nyinyi hamjui kusoma stop clock, wakaachana nayo wakapeleka kwa klasi nyingine. Watu wanakimbia race ya 10 seconds. You cannot use stop clock. By the time, in fact, they will finish before it moves. So accuracy, if a lot of accuracy is required, you work with a stopwatch. Stopwatch you need to work in here. Are you together? Yes. We prefer stopwatch because it is very accurate and it is easy to use and even to handle. It is easy to read stopwatch than stop clock. Tuendelea bado. What is the reading on the time shown on the stop clock? Let me out the book. Imeandika 10:22:4. 10 yani umepimia watu wakimbie. To record the time as an engineer. Tuambie what was that? Mtu amekimbia 10 hours, 10 days. I don't know with the gun, but the first one is then said seconds. Here, kwanza inapanga minutes, seconds, then said seconds. So we don't record time in minutes. So kija kwanza quantify for us this minute plus 22 seconds plus 34 seconds to convert 4. So it's going to be 6:22 to go back. Haya. Sasa nataka tufanye question 5, 4, 5, 6. Then to proceed to next again. But before that, kiandika hivi 0006 what will you record as the time? Are you seeing what I'm doing on the board? Bevan, are you seeing it? You cannot see what I'm doing on the board. Michelle, can you see? Okay, now what time do you record? Screen ya stopwatch ikiandika hivyo. You'll have to write 6.14. How? 0 minutes, 6 seconds, and 14 seconds. So convert this into minutes with 0.14. So it was 6.14 seconds. So instead I'm saying this, stopwatch, you have to give the readings to 2 decimal places. Ukipeana this, hata kama, okay, look here. Let me use this as an example. The same, but I'm making I know you will be tempted to say it's 6.16. Technically you are right and you're wrong. It should be up to a good decimal place, so it's going to be 6.10. It is going to be wrong. Did you hear me, Michelle? Nice. Alright. Now we can proceed with question that I have displayed on the board. Let me read to my people or my followers in YouTube. Define density per tollen if it's SI unit. That's the first question. Define density per tollen. Sorry. Define the term density and if it's SI unit. Number 2. Accurate shows a liquid level as 20 centimeters cubic. Curate. Imeread kama 20 centimeters cubic. 10 drops of the same liquid, 10 drops of the same liquid, each of volume 0.5, are added. Calculate the new liquid level. Liquid 20. Tukaongeza how many drops? Tukaongeza 10 drops, and each drop is 0.5. What will be the new reading in that particular curate? Okay, define this techniques as I need one of it to do it. Atiamujui. Namna za maji. Wewe chakona. Rege ndio zamani na ulikuwa umetoka class kwanza.
My network had gone down.
Oh, okay.
Density is mass per unit volume, and its SI unit is kilograms per meter cube.
Yeah, mass per unit. SI is kilogram per meter cubic, as 20 centimeters cubic. 10 drops of the same liquid, each of volume 0.5 centimeters cubic, are added. Calculate the new liquid level. Break unasemaje?
15 centimeters cube.
15 centimeters cubic. Let's see. Let's see. Now, you ready? When full, it is reading 0. Sasa hii yetu, the volume tumeambiwa iko 20. Somewhere here. So the more when you remove some drops, the volume of the liquid decreases, but the readings increases because itakuwa more. The reading decreases. Like in our case, 25. So in short, we added 5 centimeters cubic. So this one, ukiongezea 5 of the liquid, lakini the readings will decrease, so it's going to be 15.0 centimeters cubic. That was very correct for you, Reagan. Serikali kwanza ndio wenye wataandika waangalie nini inaandikwa. haijafungwa. Imefungwa. Haijafungwa. Sawa, I think now we can proceed. Kuna swali kwa hapo inasema an empty density bottle has a mass of 15 grams. When full of alcohol of density 0.8 grams, its mass is 47 grams. I think this question is good. I want us to analyze. Let me just a minute. I'm checking on something and I will to calculate. So nataka angalia hapa. I can write the question first. Sleep. An empty density bottle. So nikiandika tu hivi empty density bottle. Hiyo ni ngapi? Tumeambiwa ni ngapi? As a mass of 15 grams. Hiyo ni density bottle yenye aina ya kitu gani? When full of alcohol, its mass is 47 grams. So this nikiandika DP plus alcohol, that is when full of alcohol, its mass becomes 47 grams. So, now, what's the mass of alcohol? So I think I have a mass of alcohol. Mass of alcohol, it's going to be 47 minus 15. 47 minus 15, 32 grams. 32 grams is the mass of alcohol. From our question, we are told that the density of alcohol is 0.8. 0.8 what? Grams per centimeter cube. Grams per centimeter cubic. Kumbuka tunasemanga density is given by mass over volume. So for us to get the volume of the alcohol, volume is given by mass over density, which is going to be mass, which is 32 over density, which is 0.8. So from that calculation, what will be the answer? Oh, below. I see it here. Okay. That's two divided by 0.8. Remember that. Hamjapata? Hiyo ni swali kwenda kusumbua mtu. Michelle, imekusumbua? Ujui? You can imagine watu wakijua ujui that 2 divided by 0.8. Ondoa hii decimal kwanza, waje kae Pascal. 2 divided by 8 na si ni 4. Hiyo decimal place ya chini ipeleke ipo kama times 10. Nyinyi mwanzo mchezo kwa 40 centimeters cubic. Now this 40 is the volume of the alcohol that fills the density bottle. So it is called the volume of the density bottle. Volume of the density bottle. Apo Fosawa. Yeah, so let's see the actual question. Calculate the volume of water. Sasa, calculate the mass when full of water. Let me add somebody to class first. Yeah, okay. The mass when full of water. So now, if the volume of this bottle, now is 40 centimeters cubed, when you fill it with water, the mass of water will be 40 grams. Plus now, the density bottle is 15 grams. It gives us 55 grams. Nice. Thank you, Nasra, for giving me that correct answer. Aye. Now, its mass when full of mercury of density 13.6 grams. What will be the mass of the density bottle? Kumbuka, the mass of the empty density bottle is 15 grams. Now, tunataka hii kwa hii grams tuongezee mercury. Just a minute kidogo. Tuongeze mercury with a density of 13.6 grams per centimeter cubed. Kumbuka, what will be the volume of mercury? The same volume of alcohol and water, which is 40 centimeters cubed. And if density is given by mass of a volume, the mass will be given by volume times density, which is 40 times 13.6. Then you add 15 plus 15 grams, 80 grams, 40 times 13.6, then you
544.
5.4. Okay, multiply this times this. 5.4.
Yes.
Can you add now 15?
559.
Good. 559. Then we write 559 grams. Thank you. Nataka tuanze 14 through DV. So let me read question 14. Then I change something. I give you 2 minutes. Well, in fact, you can start working on question 14. A mixture is made up of two metals, X and Y. We have a mixture here which is made up of X and Y. The mass of the mixture is 30 grams. That's a up and attack. In fact, let me write this question slowly because a mixture is made up of two metals, of two metals, X and Y. Supreme, you can then do whether you can do it and write it on the board. The mass of the mixture is 30 grams. It's 30 grams. And the volume of the mixture and the volume of the mixture and the volume of the mixture is 4.5. Is 4.5 centimeters cubic. Determine, determine the mass of the metal X in the mixture. In the mixture. Alafu hapa kuna information umeambiwa density of metal X is equals to 600. 6,000, that is kilogram per meter cube. Layer Y is equals to 7,900. 7,900 kilogram per meter cube. The question is determine the mass of the metal X in the mixture. That's our question. Wacha ni focus vizuri. Sabrina amesema oni, wacha ni focus tu vizuri. What about now, Sabrina? Ama wacha kwanza nifanye hivi. Sabrina, I'm sure haionekani sahihi, right? Ama imeonekana? Is it visible, Sabrina? Hebu niandikie hapo kama inaonekana ama haionekani. The rest, you doing the question. Let me read for you the question. I think now Sabrina you can see. Wacha niondokee niuone vizuri. So I can proceed and do the question right now. Can you see it now, Sabrina? Yes. I done Beverly and Reagan and Michelle Mungai. That's funny as well. Uko na answer Reagan?
No.
Umejaribu kufanya?
Yes.
Umejaribu kufanya Beverly?
Yes.
Uko na answer?
No.
Michelle, umejaribu kufanya? Uko na answer? So the tune is yes, umejaribu kufanya, lakini answer kufanya ni sawa, lakini hapo kwanza kidogo nani, but nani Nasra I can see mimi naangalia screen nasa. Beverly, hebu ingia YouTube uone kama iko physical. Beverly, in 1 minute then come back. In fact, hata usitoke kwa lesson, just check that from my side because mimi naona ikiwa sawa watu wa YouTube wanalalamika na naona hiyo. Nasikia Beverly? Even Michelle, just check on my YouTube one how clear that statement is. Sabrina, let me read for you. A mixture is made up of two metals, X and Y. The mass of the mixture is 30 grams, and the volume of the mixture is 4.5 centimeters cubic. Determine the mass of the metal X in the mixture. Good. Now let me answer the question. Beverly, make a comment pale kwa YouTube nione kama iko clear ama iko clear. Somehow clear. Okay, I think I can proceed because okay, so two of you have told me. You can watch from that side again. Okay, now let me work on this question. Let me do this. A mixture is made up of two metals, X and Y. The mass of the mixture is 30 grams. Sasa, nataka tuende. I want us to do this. I want us to say X plus Y to be equal to 30 grams. What have I done here? Nimefanya nini hapo? I've taken X and Y to be the masses. So is this X grams plus Y grams to give us 30 grams? That is equation 1. Can you label this as equation 1? The volume is 4.5. The total volume yao ni 4.5. Hapo kama tuandika tunajuanga density is given by mass over the volume. Volume is given by mass over density. So for x which has x grams and for y which has y grams, it's very simple. The volume of x is going to be the mass of x, which is x, over the density of x. The density of x is 6,000 kilograms per meter squared. Because I've given the mass in grams, I will also give the density in grams per centimeters cubic, which is going to be 6,000. Okay, it's going to be 6 grams per centimeters cubic. So, but I will remove these things, grams and cubic. It's just going to be x over the density is x over 6 plus E here is going to be y over what that for me 7,900 kilograms per meters cubic into grams per centimeters cubic. It's going to be 7.9 over 7.9 is going to be 4.5 centimeters cubic, equation 2. Ukishafika hapo, you are almost done with the equation by the way. Kila mtu amefika hapo? Good. Now, okay. Hii nimesahau ni iko topikadi ya maths. I don't know kama iko form 1 ama form 2. Solving by elimination and substitution method. You go for? Good. Now, it will mark in the next 1 minute by day. We're supposed to be done with this. What I know is 3 grams in a final there. So x plus y is equals to 30. X over 6 plus y over 7.9. I want us to make x the subject of the formula. And to that Java, I can use here. So if x plus y is equals to 30, am I correct to say x is equals to 30 minus y? Guys and boys, if x plus y is equals to 30, is it correct to say x is equals to 30 minus y? Yes. So if x is equals to 30 minus y, nataka hiyo nimetoa kwa the first equation. Now I want us to transfer this to the next equation. Anywhere we have x, weka 30 minus y. Kidogo tu. Y is equal to equation anywhere to corner x where 30 minus y. So it's going to be x over 6. It's going to be 30 minus y over 6 plus y over 7.9 to be equal to 4.5. Sawa. Nataka to multiply LCM ya 7.9 na 6 ni ngapi? I will just take the multiplication. I will just do this.
47.4.
47.4. Madam ngapi? 47.4. Good. Now multiply na 47.4 kila mahali times 47.4 times 47.4 times 47.4. What are you going to have? Nataka to transfer pale. Sinaweza futa huku juu kama umekuwa swali, sio? Reckon, sinaweza futa huku juu. user up here?
Yes.
When you copy swali sasa sura now so we have 30 minus y into bracket 47.4 over 6. No. So can you cancel for me this 7.9, right? Am I the one? 7.9 plus by this one by this 6 plus 6y is equals to, do for me 4.5 times 47.4. Let me do it.
$213.3.
Is equals to 213.3. Thank you. Now, open for me this bracket. 30 times 7.9. Nigeria is equal minus 7.9y. So 30 times 7.9 you can get
237.
Apa tadi semua? Okay, sama. 237 minus this plus 6y is equals to 213.3. I want us to get the value of y. Do for me this. Like how to so this year the then take 213 equal to side. It's going to be a minus. So 237. Do for me this record. 237 minus 213.3 is equals to 7.9 minus 6 y. Debate 237 minus 213.3. I hope so. 23.7. 23.7. Now, apa negatif 7.9 minus 6 negatif 1.9.
Yes.
Now, what's the value of y now? Y is equals to 23.7 divided by 1.9. I hope you can calculate that. I'm a Beverly Pianist to work here. 23.7 divided by 1.9. Y negative
12.47.
12.47. Now, to show the value of y, peleka hapa. Sema x plus 12.47 is equals to 30. X plus 12.47 is equals to 30. Now, x is going to be x plus 12.47 is equals to 30. X is equals to 30 minus 12.47. Ukapata kati?
17.53.
17.53. That is what we were supposed to be looking for. Swali imeuza determine the mass of metal X, 17.53 grams. Sema iko sawa?
Yes.
Okay, thank you. Ndaka tuende question 13. Question 9. Ndaka sorry. 29 kwanza. A butcher has a bean balance. I will clear the board so that I can write another question. A butcher. Can you comment on the YouTube kama inaonekana tunaandika a butcher has a bean balance? Bean balance. and masses. Just drop a comment yun and masses 0.5 kilogram and 2 kilogram. Swali ni gani? How would he measure? How would he measure? How would he measure 1.5 kilogram of meat on the balance at once? Of meat on the balance at once. Let me see, come up. Inaonekana? I want to see what the... Yes, Reagan?
And he places the 2 kilogram one on one side. Then on the side where the meat is placed, he also places the one with 0.5. Then it should be measured, since the 0.5 is on the side of the meat, it should have removed from the 2 kilograms, making it 1.5 kilograms.
Okay. Somebody another could explain. Sioni from my side. Just check if this Nimaandika is feasible. So I'm saying a butcher has a B balance and masses of 0.5 kilogram and 2 kilogram. How would he measure 1.5 kg of meat on the balance at once? Let me explain that concept as I'm waiting for you to become eco-feasible. Eco-feasible. Okay. Sawa. P-balance kinagana hivi. So hii tu ni mahali unaweza wekelea whatever you want to measure. But so this person has a mass of 0.5 kg. Hizo basi zinaganda hivi blocks hivi. Na ingine ni amesema ingine ni 1.5, na ingine ni 2 kilogram. Hii 1.5, hii ni 2 kilogram. Another kupima, how would he measure 1.5 kilogram of meat on the balance at once? Fenye tu Reagan amesema atachukua mass. Let me remove this box. Atachukua mass ya 2 kilogram aweke hapa. Hii ya 2 kilogram. Akishaweka hapo, of course, akichukua the mass ya 0.5 aweke hapa, it will not balance. Itakaa hivi. But akiwekelea nyama, you know now the difference between 2 and 0.5 is 1.5. So ile nyama ita balance 2 kilogram. Akiongeza 0.5 kilogram mass, it will be what you wanted to measure. Are you together? Is all umeelewa? Okay. Now, tell me what of this one in make sense. Yeah, we show. It's only 3 minutes to the time. Aye. Good. Tunafanya question 10. It's our last question. For today. Can you try putting them as I'm writing it on the board for those who are watching me? Let me take the question. The mass of an empty density bottle is 25 grams. Let me share it by me. Oh, you can have time in the book. I don't like this pen. I don't like this the most. That one. You guessed it. Pen. Shamushu. Let me use this. The mass of an empty density bottle. Empty density bottle. How much? 25 grams. When full of water, Ligabi, 50 grams. Sawa? And when filled with formalin, density bottle plus formalin is whatever 60 grams. Formalin is certainly produced in hospital. Calculate the mass of water. Sasa, when full of water is 50, when empty is 25, so mass of water. So this is going to be 25 grams. The other question is volume of water. So density is going to be 25 centimeters. Why? Mwambiwa ni 5 minutes to myself. So volume of water is going to be the same as the mass of water because the density is the same thing. Then volume of the density will be the same as the volume of water. So I didn't get it. So I get a mass of formalin. This total plus formalin is 60. This total is 25. So 60 minus 25 negative. That's 5. So mass of formalin. That's 5 grams. Volume of formalin is our volume of water because if 25 should be in a field, then formalin getting 25. So So density of formalin is going to be the mass of formalin, which is that 5 divided by 25. Use your calculator, you get it in grams per centimeter squared. Umefanya swali? Reagan, uko clear?
Yes.
Okay, sawa. So nataka tuachie hapo leo. Tomorrow we will be doing, tutakuwa tukifinalize chemistry classification of substances, simple classification, and but tomorrow we are doing GCSE practicals. I may be in school, but I will communicate in the group. Yes. Have a nice evening, everyone.